Conference will now be recorded.
Good morning, all of you. I hope everybody can able to see my screen. Please respond me, guys. Everybody can able to see my screen or not? Amarnath, Divya, Leela Krishna, Myanasa, Ravit,
Yes, sir.
Pawan, Siddharth. Very good, very good. Shravan.
Visible, sir.
Right, sir. So yesterday we discussed about different kind of machine learning types: supervised learning, unsupervised learning, reinforcement learning. Am I right? Okay. Today I'll go through the practical how supervised learning will be. Let me open collaboratory. So in supervised learning, the first one is a linear regression. Am I right? Can anyone see the diagram and tell me? Just 1 second. I want to. Gen AI. Sir, I uploaded all these diagrams and shared with your email IDs. Please check it out. Please check it out. Your email IDs. I already shared these images also. If anybody not received, please give me your email ID. I will share with you. I will share with you. Okay, the first one is the linear regression. In supervised learning, the first one is linear regression. Okay, let me go through the linear regression first. So come to collaboratory. Okay, just go down. Very good. Now I just start with the linear regression now. Linear regression model. Please mute, sir. Please mute, sir. Other people will disturb. Linear regression. So, what is the meaning of linear regression here? Predicts continuous numeric values. Continuous numeric values. Okay, straightforward. I want to go through the example. So in last class, we discussed one simple example. So previous months, some salaries are going to be happening. What is the next month salary? Or previous years, some salary growth is going to be happening. What is the next year growth salary? Something like that I want to predict. Based on the previous data, we want to find out upcoming data. So machine is not a god. Machine learned by the data, and based on that, it will give you the predicted output. So here the formula, very simple formula: y is equal to mx plus c. This is the simple formula what linear regression follows. Y is something like output, x is something like input. There are multiple kind of inputs, input features we are going to be giving. So here y, what is the y have? Predicted output. Y is what? Predicted output. Y is something like predicted output. What is the x here? X is something like input feature. Features. Y is something like input features. And M is something like a slope. M is something like a slope or weight, whatever it may be. Slope or weight. And finally, C is something like a bias value. Okay. Let's straightforward. I go with the program. how we can able to work with the program for the linear regression. Okay. First of all, we want to take, sir, can I improve the font or this is okay? From sklearn, from sklearn dot model, from sklearn dot model. What is the model we want to take here? And model selection, select the model. What kind of model we want to take? Import train test split and sklearn linear model. Linear model I want to take. Accept it and import linear regression. Import linear regression. This is the thing we have to give first. And one more thing, I want to import pandas also. Import pandas as PD. Import pandas as PD. This is already we know. This is already we know. Import pandas as PD. Okay, just execute it. Sir, sklearn.model selection, train test split. We have to split the data into the two ways. One is the trained data set, one is the test data set. And the model selection, what is the model selection? I'm going to be working with a linear model. Okay, this was executed. Now I want to define some data set. I want to define some data. This is a simple data. This is a simple data. So based on the square feet, I want to find out the price. Based on the square feet. Okay, based on the square feet, I want to find out the price. So square feet, I'm going to be giving 800 square feet. What is the price? 900 square feet, 1000 square feet, and 1200 square feet, 1500 square feet, and 1800 square feet, 2000 square feet. For this, okay, comma, this is object, this is dictionary, and for this I want to define some prices. Okay, 1 2 3 4 5 6 prices I want to give. Okay, 6 prices I want to give. So for this, 800 square feet, 40 lakhs, 50 lakhs, 65 lakhs, 75 lakhs, and 90 lakhs, and 10 lakhs. So this is what actually my data is. Now let me go through the data frame. Data frame is equal to pd.data frame. pd.data frame. We already know pandas, right? We already know pandas. So based on that, I am defining my data. So finally, what is the df here? Okay, just check the df now. This is the df. Based on the square feet, I am actually giving the prices. Based on the square feet, I am giving the prices. Okay, after that, I want to train the data. Train data for machine, for model. Train data. So x, for x, what I want to give? For y, what I want to give? Sir, for x, what I want to give, sir? Input. For y, I want to give the output. X is equal to df of square feet. Square feet. What is the property I'm giving here? What is this one? Square feet I want to give. Square feet. For x, I'm training with this. For y, I'm going to be training with this. And y is equal to df of price. I want to give the price for this. This is the price. For x, I'm actually training with the square feet values. For y, I'm giving price values. Then finally, what I want to do? X train, X test, Y train, Y test. What is X train? What is Y train? What is X train? What is Y train, sir? I want to define some variables here. X train, X test, Y train, Y test is equal to train test split. Okay, train test split. What I want to split the values like X comma Y comma test size 0.2 or 0.3, whatever you want. Okay. Sir, for testing, I am giving 20% data or 30% data. For training, I am giving 70% data. For testing, I am giving 30% data. 0.3 means what? 30% data I am using for the test size. Remaining 70% data I am using for the training set. So X train, X test, Y train, Y test. All these are variables, sir. All these are variables. Train test split is going to be, test size is going to be 0.3. Okay, now you can train the model. Now model is equal to, okay, I want to define the object called model. Model is equal to linear regression. Already we have imported linear regression. Model.fit X train, Y train. So training data set we are giving first of all. Model training process. Model training process. Now model is training, sir. Now model is training with your trained data set. Now finally I want to work with the production. Finally I want to work with the production process. Production process. Take the production. Take the production. Production is a simple variable I am going to be taking. Production is equal to model dot prediction, not predictions. Production model dot predict X test data. For the production, I am giving the value like already we have some values. Already we have some values like 800, 1000, 1200, 1500, 1800, 2000 already given. These are the different data set machine already trained with. For 800 price is 40, for 1000 price is 50, for 1200 price is 65, for 1500 price is 75, for 1800 price is 90, for 2000 price is this much. But what about 1600? I don't have any 1600 here. What about production of 1600? For 1600 square feet. For 1600 square feet, what is the production? For 1600 square feet, what is the production? Okay. So let me print the production here. What is the production output is? Some production output is going to be array. Production output is going to be array. Now I want to go for production of 0. I want to go for production of 0. Production of 0 means it will print the first index. So production of 0, something like 80.93 is giving. Production value something like 80.93 lakhs it is giving. Okay, let me give one thing. I want to print this output like printf predicted price and comma prediction of 0. Then you can close this. Okay, now you can execute it. What is output, sir? What is output? Predicted price is what? 83. Predicted price is 83. So 83 for what? 83 for what? 83 for what? Which square feet 83? Sir, machine got trained with 800, 1000, 1200, 1500, 1800, 2000. But I am asking like what is the price for the 1600 square feet? Or what is the price for 1650 square feet? What is the price for 1600 square feet? Please give me. Okay, some parenthesis is missing. Okay. What is the price for 1650 square feet? If I am asking what is the price for 1650, it is giving 87 lakh dot 52,000. Am I clear, sir? How to work with the linear regression model? Am I clear how to work with the linear regression model? What is the linear regression model? You have the input, you have the output. You have the input, you have the output. We are training the machine with the input data and output data. We are training the machine with input data and output data. Finally, I am asking, what is the price of this? What is the price of what I'm asking? Like 1650. 1650 square feet. What is the price? Now machine is telling like 87.52 lakhs for the 1650 square feet house. Am I clear? Linear regression model. Amarnath, Chandu, Dilip, Divya, Karthik, Leela, Krishna, Mansa, Rohit, Sandeep, Siddhartha, Shravan. Is this clear? Linear regression model or any question? Leela, Krishna, yes, I will share. I will share the collaboratory with you, and I will share the folder with you. I think you're the first day you are attending the session. Can you explain the model? Exactly. I will explain the model. Sir, first of all, linear regression is something like input values with output value. Okay, so for linear regression, if you want to work with the supervised learning linear regression model, first sklearn, scikit-learn is the library for all the supervised and supervised reinforce. Scikit-learn lot model selection, import trained test split. Scikit-learn dot linear model I want to take with linear regression. So in linear models, there are multiple regression models are there. One is the linear regression, one is the multiple linear regression kind of things. Pandas using for to show the data kind of thing. If you want visualization, I will show the visualization also. If you want visualization, I will show the visualization also. Is this clear? Visualization is not that much required. If you want, you can go for the visualization. Visualization is optional, sir. If you want, you can visualize it. If you want, you can visualize it. Can I show the visualization for this? If you want visualization, visualize in plot. In plot. Okay, so for visualization, one library important. What is the library for visualization? What is the library for visualization? Import matplotlib. Matplotlib. Matplotlib dot pyplot as plt as plt. Now plt dot I want to go for scatter plot. Let me go for the scatter plot for this. This is giving but not giving. Huh? What is this? Scatter plot I want to define with. Let me define the scatter plot. Okay, df of now what is the value I want to take like square feet? First one is square feet, comma df of price. df of price. These two values I want to go with the scatter plot. If you want to show the label, you can show the label also. What is the label you want to show? Like label is something like actual data, something like. This is the first one. First line you have to go for. Now you need to plot the values. Plt dot plot. Plt dot plot. Plot. For plotting, you have to define like a df of. Yes, this one I can able to accept it or not. Sorry, not able to accept. Okay, df of I want to take the square feet first. Square feet. The first one is square feet. Then model dot product. What is the model dot product value? Model dot product. Please accept it. Why this is not accepting? Product. What is the production here? df of square feet. df of square feet. Comma label. For label, I am giving like a regression line. Regression line. For label regression line. The prediction value for the regression line. Let me execute it. It will work out or not. Something issue. Data frame object is not defined. Matplotlib dot as plot. Df is not defining. Import pandas as pd. Pandas as pd. That was done. Okay, type error, scatter, data frame object is not callable. Data frame object is not callable. Okay, one thing I will do, we keep this one here only. Data frame object is not callable. What's the problem? Let's keep this one into the same line. Why? Because data frame is not calling over there. Why? Because data frame is available here. Still we have the issue. Explain the error and close it. Accept and run. Okay, now I got the visualization. And predicted price, this one. Okay, still you have the issue. Two-dimensional container but loss the series instead of past data frame containing with. Some issue is there here. Can you see this? df of square feet, df of price, then label. That is okay. And plt.plot square feet, model dot product, df of square feet. Okay. Here. Okay, visualization having some issue. Here I need to take two square braces. One second, sir. Actually, the output came, but still it is resolving the things. Two-dimensional container we want to take. Yeah, this was replaced to this one. That was done. Close it. So this is the predicted value. The straight line is going to be taken like this, and predicted value I got. The predicted price is 83.09. Okay, that cells you can remove. That error cells you can remove. Just remove the error cells here. The output is this one. So the predicted price is 86.44, and I got a line properly. Predicted value somewhere I taken. What is the predicted value I taken? Like 1600. What is the production price? 1650. Where is the 1650 available? 1650 is available somewhere here. 1650 is somewhere available here. And the prediction, this is a straight line which is going to be taking with the data, and through the straight line I can able to predict some value. This is simple linear regression. This is simple linear regression. Then what about the multiple linear regression? Multiple linear regression. So for the multiple linear regression, we want to take the multiple inputs. Multiple linear regression. This example yesterday I told. This example yesterday I told. What is the multiple linear regression then? Sir, for multiple linear regression also, we want to take the same Same things like this. Just copy all these things, and here for multiple linear regression I want to work with the data. Data is different now. I want to take the data with multiple parameters. The first one is square feet. Okay, square feet and prices I will take from that. Square feet data I'm taking from this, and price values also I'm taking from this. But I want to give the multiple inputs here. I want to give the multiple inputs here, not only the square feet value as the input, not only the square feet value as input, I want to take the number of bedrooms and age of the house also. Copy this data, come down, paste here. Okay, I have the square feet, sir. After that, I want to take the number of bedrooms. Okay, BHK, accept it. And after that, I want to take age of the house. Age of the house. Age of the house also, total 6 values I want to take. The first house age is 10, second house age 8, third house age 5, and 4, comma 2, comma 1, something like that. Okay, so then comma and price. So here multiple linear regression, what is happening, guys? For multiple linear regression, multiple inputs we are providing. We are providing square feet, we are providing BHKs, we are providing the age also, and final output will be the price. Now just data frame define, df is equal to pd dot data frame, pd dot data frame, and pass the data frame, and pass the data for that, pass the data for that, and just to display the data frame then, just to display the data frame then. Okay, now my data frame is like this: number of square feet, number of BHKs, and number of age, and price is this much. But I want to find out 1650 square feet with number of bedrooms and number of age also I want to provide as the input. Okay, my input is different now. Based on my input, it will predict the output. Okay, let me go through that. So df is defining. Now x is equal to, now I want to define the x. X is equal to df of square feet BHKs. Okay, one the thing is square feet. Sorry, small letters. Huh? First one square feet. Second one BHK. Third one age. Third one age. Okay, then y. Y is df of price. Y is df of price. Now train the data. So x dot x of train, x train, x test. Okay, this one I want to accept it, not accepting it. Y train, y test. Sir, these are variables, sir. These are variables. For these variables, I want to take the data from this. Train data, train test data, train test split. This is the method, defined method, predefined method. This is the predefined method. But my data should be taken from x comma y comma test size. What is the test size you want to give? I want to give the test size 0.3. 0.3 is my test size. Then I want to give the one more property over there, random state also. I want to give the random state is equal to something like 42. Okay, random state is not defining. Yeah, coming. Fine. Now model is equal to which model you want to take? Same linear regression model, and model dot fit the data for the model, model dot fit what the data I want to fit here: x train, y train, x train, y train. the model is fitting with something. This one not required. Okay. So model is fitting, sir. And after that, I want to give the input, the new house related data. Okay, new house production. For new house, I am giving the values like production is 1650, 3-bedroom flat, 2 years age, 2 years age. Then predicted output. Now finally, I want to print the new house predicted price. New house predicted price. New house predicted price. How to get the new house predicted price? Already new house, this one, new house of 0. That is basically array. You will be getting the output like array. Okay, so execute it. Multiple linear regression. So for the multiple linear regression, new house predicted price is something like why this is giving minus value. Is there any mistake we are doing? So what is the new house predicted price, sir? 10,035. 10,035. Why? Because this is 2-bedroom flat and age of the house is what I'm giving the values here. Values are very important. One second. Model dot predict. First of all, we need to define the new house with values. New house is equal to, I want to give something like 1700 already there. I will give 1650 comma 3 comma 3. That is fine. That is my new house. Now production. Now production values for production is equal to, now this one production of 0. That is fine. New house price production. New house price production. Okay. New house price production of 0. That will be great. Now it will give you the proper output. Okay. New house production output is 100. That is correct. So this one I am giving 800,000, 1200, 1500, 1800, 2000 square feet, and BHKs also I am giving, and age of the house also I am giving, and price of the houses also I am giving. But new house I am asking like a 1650 square feet. For 1650 square feet, 3 years age house, 3-bedroom flat. If I take 2-bedroom flat, the price will be reduced. If I take 1-bedroom flat, or 2-bedroom flat. So previously the production is 100. Now the production will be less. 130. Why 3 years age? Let me give the 5 years age house. If it is the 5 years age house, it is 335. 335. Sir, based on your data, it is going to be giving you the output. Based on your data, it is going to be giving you the output. Okay, so 1650, or let me go for 650 square feet. Only 650 square feet. 1-bedroom flat, and age of the house is 10. I'm changing the data. It will be new house production is 270. This is too much. What is happening, sir? I just delete the random state here. Yeah, this is what random state delete. Now new house price is 36 lakhs. 36 lakhs is less or not? 36 lakhs less than 40 lakhs or not? I am asking just 650 square feet house with a one bedroom flat, 10 years age. But if I improve the age of the house is 2 years, if I improve the age of the house is 2 years, now your output will be little bit more, 36 lakhs. This is the way you can able to work with the, this is the way you can able to work with the multiple linear regression. This is the way you can work with the multiple linear regression. Any questions on this? Leela Krishna, in X train, Y train, what the values we are sending? In X train, we are providing the data. In X train, we are providing the data, these values, Leela Krishna. In X train, we are providing the data, these values. Square feet, BHK, age. In Y train, we are providing the value like prices. X train, we are providing these values. In Y train, we are providing these values. But finally, we have to go for the Y test. Y test. Why? Because testing is only the needed one. Testing is only the needed one. For train the model, you have to give the splitted data. You have to give the X train data, you have to give the Y train data to fit the linear regression. To fit the linear regression. And finally, prediction is test data. Prediction is test data. The Y test is a variable. Y test is a variable that is a predicted output. And Y train value, we are giving the values here for training. The new house values, whatever we are providing over there, 650, 1, 2, that is my predicted values. For this predicted values, what is the output I am asking? What is the output I am asking? See, if you don't understand this, I go through the paint. I go through the paint. If you don't understand this algorithm, I go through the paint. Okay, so all these are predefined methods. All these are predefined methods. You don't worry about it. Okay, let me have a simple diagram here. This is the multiple linear regression. So here we have the square feet. We have the number of bedrooms, and here age of the house, and finally price of the house. Price of the house. These are the values. So square feet of the house, we are providing the different data. For square feet, 800, number of bedrooms 2, age of the house is 2, and price of the house is something like 40 lakhs. 40 lakhs. In this way, we are taking the data set. In this way, we are taking the data set. 900, 3-bedroom flat, age of the house is 3, price of the house is 60, 1000 square feet, 2-bedroom flat, age of the house is 4, and this one is 70 lakhs. And one more, I want to take 1000 square feet and 1200 square feet, number of bedrooms 4, age of the house is 5 years, price of the house is 90 lakhs. So this is the data we are giving to the machine. This is the data we are giving to the machine. This is the data we are sending to the machine. We are training machine or model. Machine nothing but model. This is the model. So now model is training with this. Model is training with this, and model is testing with this. Model is training, model is testing. Train and test. Train and test. So training is happening with 70% of the data. Training is happening with 70% of the data. Testing is happening with the 30% of the data. And finally, I am giving a new input value for the machine. A new input value. If I am giving new input value as 800, 3-bedroom flat, age of the house is 2. Now my question is, what is the price for this? What is the price for this? I am giving the new value, sir. Model trained with the different values. Model trained with the historical data. model already trained with the historical data. And finally my question is what is the price of this particular parameters? Now I am giving new parameters, sir. Now I am giving new parameters. When you are giving the new parameters, now you are giving the new parameters 800, 3-bedroom flat, 2 years age of the house. What is the price? Now this model is going to be checking like, now this model is checking like 800, 900, 1000, 1200 by the number of bedrooms, by the number of age. Price is already trained. Based on that, it will give some price for you. It will give some price for you. This is the explanation of multiple linear regression. Normal simple linear regression, single input, single output. Single input, single output. But now I want to check the accuracy score. What is the accuracy score of this particular model? What is the accuracy score? If you want to find out the accuracy score, you need to check with the from sklearn dot metrics import r square value. So r2 score. What is the r2 score for this? So whatever the y prediction we have is equal to model dot predict. Let me give this also in the same way. So x test. What is the x test we have? This is the x test data we are giving, right? So based on that, I want to find out the r square value for this. Okay, this variable is not available here. Let me take this and go for here only. Already x test is available now. It is x test. Small letter or capital letter? This one, x test. Okay, finally, I want to print the r square value. Print r square value to score. Now r2 dot score from the y test, y prediction. R2 score of y test, y prediction. Y test, y prediction. By the prediction value, by the tested value, I want to print out the r square value. Okay, just execute it. Okay, so r2 value is minus 32, something like this. Okay, let me do one thing. Cut it and keep in the this one. This one already executed. Multiple linear regression already executed. So house prediction already there. Now I can execute this one. Now the prediction value R2 score is 0.97. 0.97 accuracy. This is the R2 score. This is R2 score. Am I clear, sir? But is this good fit? Is this good fit algorithm? Good fit for model? 0.97 is good fit, bad fit? Sir, nearby 80% accuracy it is actually giving. Nearby 80% accuracy it is giving. But we want how much accuracy? We want how much accuracy?
98, 99.
98, 99, 95 to 98 also okay. At least we are just taking the sample data, but data is not looking good actually. This data is some dummy data. This data is some dummy data, but in the real time you will be getting the good data, good historical data. But model is working or not? At least the model is working or not? I can able to get some accuracy and I can able to get some prediction. All these things are working. All these things are working. So model is working, but you work with the real data sets. You work with some more data sets, some more accuracy data sets, then you can able to understand how the things are getting worked with. Am I clear, sir? This is the way of working with the linear regression. Let me try to work out logistic regression now. So what is the logistic regression? What is the logistic regression? Logistic regression. This is the linear regression. This is the multilinear regression. Multilinear regression. Linear regression. This is a multilinear regression. Now tell me about the logistic regression. Yesterday I told you, no? What is the logistic regression? Logarithmic value I want to get. Either zeros or ones. True or false. True or false. Live or dead. Pass or fail. Pass or fail. These kind of outputs I want to see. These kind of outputs I want to see. Okay, so this is something like a logistic regression. For logistic regression, my output should be something like a 0 or 1. My output should be like 0 or 1. Okay. Let me go with the sample data. Let me go with the logistic regression now. Logistic regression. Import pandas as PD. Pandas as PD. Next, import sklearn. Import sklearn dot model selection. Import train test split. Train test split. And one more import needed. sklearn import needed. Import sklearn, a linear model I want to take. From this, I want to take a logistic regression. Import logistic regression. Capital letters. Logistic regression. Train test split is over, and this is the sklearn linear model. And import logistic regression. Yeah, this one, logistic regression I want to take. And after that, accuracy score also you want to find out. For example, import, one more import needed, and matplotlib. If you want to visualize, you can take the matplotlib also. And one more import needed. Import sklearn.metrics. sklearn.metrics import accuracy score. This is also needed. Now define the data, sir. So first of all, execute all these things. Okay, invalid syntax. sklearn model selection train test split. Okay, sklearn dot model selection import train test split. Import train test split. This one I want to take it. Train test split. Okay. Let me execute again. If you have the issue, just explain the error. Where is the problem? It will rectify. Collaborator will rectify you. Okay. Accept and run. Let's close it. Okay. That was already there. Google Gemini API is going to be working with you and it is testing with you. Where is the problem? Some small letters, capital letters kind of thing. Now define the data, sir. Data. Data is Python object, Python dictionary. Now I want to take a data of students. Data of students, how number of hours they practiced, they passed or failed. Number of hours they practice. Okay, so I took something like 2 comma 4 comma 6 comma 8 comma 10 number of hours they practice. Okay, I'm taking only 5 values, or let me take 14 hours practice. Number of hours they practice with, and they pass or fail I want to check with. Okay, pass. Sir, here values, what kind of values I can able to see here? Anybody? What is logistic regression? What is logistic regression? It may be 0 or 1. It may be true or false. It may be live or dead. It may be pass or fail. This is logarithmic value, a Boolean value. In logistic regression, we want to find out the Boolean value outputs. Linear regression, I want to find out the numerical value outputs. But in logistic regression, I want to get the Boolean value outputs. Okay, so here, pass or fail, I want to check it out. Okay, let me give here only 3 hours. Okay, for 2 hours, he failed. For 4 hours, he failed. For 6 hours, pass. 8 hours, pass. 10 hours, pass. 3 hours, fail. 14 hours, pass. That's it. This is the data. This is the data I'm giving to the machine. Now, df is equal to pd dot data frame. df is equal to pd dot data frame. I want to define the data frame. Capital letters are data frame. Define the data frame with data. Already we have the data now. Just pass the data. Now define the df. Now execute it. Your df is very clear. Your table is very clear. The number of hours and pass or fail. 2 hours he did practice, pass 0. 4 hours he did practice, pass 0. 6 hours did practice, pass 1. 8 hours practice, pass 1. 10 hours practice, pass 1. 3 hours practice, failure. 14 hours practice, pass. Sir, I given the data for the system. Now the process is fit the model. Split the data and fit the model. Splitting input and output stuff. Now splitting inputs and outputs. Let's go. Now split the data. Splitting inputs and outputs. Splitting inputs and outputs. Okay, now splitting the inputs and outputs. X is the input. df of hours. Okay, df of hours. Okay, hours. Sir, what is the variable you are taking here? The same variable you have to take. Let me take a capital H here. Let me take a capital P here. Okay, number of hours I want to take as input. Number of hours I take as input. Then y is equal to df of pass. df of pass. Okay, so now splitting the data. Splitting the data with x and y. After that, train, test, split. This is very much important. Train, test, split. For this, x train, comma x test. Yeah, this is giving. You can take it, accept it. And the test size. What is the test size I can give? 0.3. 30% data I want to use for testing part. 30% data I want to use for testing part. Now train your model. Train model. Okay, model is equal to logistic regression. I want. Yeah, this is giving. You can accept it. Train the model, logistic regression, model dot fit, x train, y train. Now the prediction. So prediction for y prediction, right? There is a y prediction value I want to define. Y prediction is equal to model dot predict. Automatically model.predict is accepting model.predict X test. Model.predict X test. Model.predict X test. I want to take the X test value. Finally, so you can print this Y prediction value. Finally, you can print this Y prediction value. Y prediction. Okay, execute it. My predicted value. What is the predicted value over there? Okay, key error, pass test. Okay, df of hours, df of. Okay, I want to execute this one more time. Why? Because I changed the variables now. I changed the variables now. Just and execute this one more time. That was executed. My array is 0, 1, 1 came into the picture. My array is 0, 1, 1 came into the picture. But my accuracy, I want to check it out. My predicted value already there. So y prediction is equal to model.predict X test. Test value I want to give now. So model.predict X test. X test. Now print your prediction. Okay, so print the accuracy of this. Print y predict. This one actually needed. Execute it. Okay, 0, 1, 1 came into the picture. Prediction is there. Now I want to check the hours. Now I am giving the input. New input I am giving. Now he practiced 6 hours already given. 6 hours I already given. Now I am giving like 5 hours. For example, he practiced only 5 hours. Hours practiced only 5. Hours practiced only 5. This is hours I am giving. Now you can go for production. Model dot production hours. Now production is needed. Production is equal to model dot predict the number of hours you have to pass. Okay, predict. Now this one, the number of hours he practiced. What is the number of hours he practiced with? 5 hours. I am passing 5 hours here. If you pass 5 hours, what is the prediction? Now finally, if prediction of 0 is 1, something like student will pass. Yes, very good. Now execute it. Student will pass. Student will pass. Why? Because prediction of 0 is 1. Student will pass. Prediction of 0 is 0. Student will fail. Now prediction of 0 is 1. 1 came. 1 came means pass. Student already passed. Sir, here check it out. 2 hours, 4 hours, 6 hours, 2 hours failure, 4 hours failure, 6 hours pass, 8 hours pass, 10 hours pass, 3 hours failure. But I given what? I given 5 hours. I given 5 hours. Can you see where is my value I given? Where is my hours? 5. Okay, if I give hours 1 hour only he is doing practice. 1 hour only he is doing practice. Sir, 1 hour he practice. Student will fail. Student will fail. Is this so? Is this logistic regression is working properly or not? If I am giving the value, 1, student fail. If I give the value 5, student pass. If I give the value 7, 6 already pass. 7, 8 is also pass.
Pass.
If I give 7,
Pass.
exactly. If I give 7, student pass. Sir, now model trained with the historical data. Model trained with the historical data. Based on that, it is predicting some output. This is called logistic regression. I told you there are two kind of supervised learnings. One is a linear regression, multilinear regression, and logistic regression. What is the kind of outputs you can see in the linear regression? Based on the number of square feet, based on the number of bedrooms, based on the number of age, the prices will be defined. This data trained by the model. But if I give new value, something like 950 here, for 950 3-bedroom flat, 4 years 5 years house age, what is the price of the house? If I ask, it will give the output properly to you. That is the linear regression. But logistic regression is not like that. Logistic regression is giving the Boolean values. Sir, you can work with the multiple data sets. You can work with the COVID data set. With the COVID data set, number of parameters, person alive or person dead, something like that. You try with the multiple data sets. So logistic regression will give you the Boolean outputs like zeros or ones, true or false, live or dead, pass or fail. For this pass or fail, I give an example here. I hope you people got understand about the linear regression and logistic regression. Tomorrow we'll go with the support vector machine, at the same time random forest and some unsupervised learning. 1-2 days. Tomorrow we'll close this algorithm level. The Monday onwards we go through the LLMs. Or if it is possible, Saturday also I will take the session, and Saturday I'll close with LLMs, with RAGs and all. How to prepare Google Gemini API, and how to use this Google Gemini API with our LLMs. How to prepare a simple chatbot also using with a generative AI in deep learning techniques. Hope everybody clear. Divya, Karthik, Mansa, Rohit, Sandeep. I'm closing the session, sir. See you. Tomorrow we'll meet. Have a nice day. Please like the video, share the video, subscribe the channel. Yeah, process is same for any data. Divya. Data set will change, but process is common. Working process is common. A model selection is important. Fitting the model is important. Train the model is important. Production is important. Please like the video, share the video, subscribe the channel, click on the bell icon for the further notifications. And your comments are valuable. Please provide your valuable comments also. We'll have a session tomorrow. Saturday also I will take a long time. Saturday we'll have LLMs for this week. Have a nice day. See you signing off.
Thank you, sir.
Thank you.
Thank you. Thanks a lot.